Hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Hi, soaked in. Welcome. Today, we always explore how current LLMs falter in reasoning. Discover the Hierarchical Reasoning Model, HRM featuring worker and controller modules. We'll see how HRM's innovative training and architecture conquer, like complex tasks like Sudoku and pathfinding, surpassing other powerful models. Can you explain how the limitations of current large language models, LLMs and reasoning tasks motivated the development of the hierarchical reasoning model? So,
Current large language models, LLMs face significant challenges when it comes to reasoning tasks, much like a student who struggles with math problems that seem so easy to their friends. These models often find it hard to solve tasks that humans can handle with ease, such as complex puzzles or navigating through large mazes. This really difficulty arises because the existing models aren't designed to mimic the way humans think and learn. One major limitation is that these models are not deep enough. Imagine trying to build a really tall tower with blocks. If the blocks are too flimsy, this tower just won't stand. Similarly, when LLMs stack more layers to improve their reasoning, they encounter problems that prevent them from learning effectively, so a situation known as vanishing gradient. Additionally, LLMs rely on a method called backpropagation through time, which is basically like trying to retrace steps in a maze after making a wrong turn. This method doesn't align really well with how our brains actually learn and reason, which is more sophisticated and flexible. These limitations in current LLMs have prompted the development of the Hierarchical Reasoning Model, so HRM. The action LLM was designed to overcome these challenges by incorporating a structure inspired by the human brain, enabling it to reason better and tackle tasks that were previously difficult for AI. This new approach is just like giving the student better tools and strategies to solve math problems, allowing them to excel where they once struggled.
What are the key components of the hierarchical reasoning model? Particularly the roles of the controller and worker networks, and how do they interact to enhance reasoning capability?
The Hierarchical Reasoning Model, HRM, is built with 4 key components that work together to enhance its reasoning abilities, so much like a well-coordinated team. 2 of these components are the worker module and the controller module, each just having its own important role. The worker module, also known as the low-level recurrent module, is like a really diligent worker bee. It focuses on detailed computations and handles the kind of nitty-gritty tasks that require quick processing. This module works really fast, allowing it to tackle specific problems and gather information efficiently. On the other hand, the controller module, or the high-level recurrent module, acts like a really wise teacher. It takes a step back to really think about the bigger picture and engage in more abstract and deliberate reasoning. This module works at a slower pace, ensuring that the overall strategy is sound and that the reasoning process is so well thought out. These 2 modules interact in a complementary manner. So the worker module provides detailed insights and computations to the controller, while the controller guides the worker by setting the direction for the reasoning process. This teamwork mimics how our brains process information, where quick reactions and thoughtful analysis work together to solve complex problems. By combining their strengths, the HRM can actually tackle reasoning tasks more effectively than traditional models.
So how do innovations like hierarchical convergence and one-step gradient approximation in the HRM contribute to its training efficiency and overall performance on complex reasoning tasks?
Innovations like hierarchical convergence and one-step gradient approximation in the hierarchical reasoning model, HRM play crucial roles in enhancing its training efficiency and performance on complex reasoning tasks, much like just having a smart strategy in a game that really helps you win. One-step gradient approximation is like a shortcut and like a maze. Traditional methods require a lot of memory and time to calculate gradients, which are essential for learning. This is similar to needing to remember every turn you took in a maze to just find your way back. However, with just one-step gradient approximation, once the model reaches a stable point, we can learn more efficiently by treating earlier steps as fixed and only focusing on the final outcome. This means it can learn faster and make better use of the resources available, like a player who knows the final goal and can just skip unnecessary steps. Hierarchical convergence addresses the problem of early convergence where the model actually starts to learn less as it approaches a fixed point. So imagine a runner who slows down as they near the finish line. they might stop improving, altogether. Hierarchical convergence helps keep the model learning effectively by slowing down this whole process, allowing it to continue making progress and refining its understanding. So together, these innovations allow the HRM to train more efficiently and achieve better results on challenging reasoning tasks, enabling it to outperform other models with a smaller amount of data and fewer parameters. So this is akin to a team that uses smart strategies and efficient practices to achieve great results with limited resources.
What specific complex reasoning tasks, such as Sudoku or optimal pathfinding, were used to benchmark the performance of the hierarchical reasoning model, HRM? Oh yeah, and how did it compare to other powerful models in these tasks?
The hierarchical reasoning model, HRM, was benchmarked on several specific complex reasoning tasks, which include one sort of Sudoku. So extreme, this consists of highly challenging 9x9 Sudoku puzzles that require careful logic and deduction to solve. 2. Maze hard. This involves complex 30-30 mazes that test the model's ability to find the optimal path from start to finish. So, 3. ARC. AGI challenge a data set that presents IQ-style puzzles designed to assess general intelligence and inductive reasoning. Like in these tasks, the HRM demonstrated remarkable performance, achieving nearly perfect results on both Sudoku puzzles and optimal pathfinding challenges in large mazes. In stark contrast, other powerful models such as O3 Mini, High Claude 3, 7-8K, and DeepSeek Roan struggled significantly, showing zero accuracy on these tasks. So furthermore, the HRM also outperformed these models on the ARC AGI benchmarks, tackling the challenges directly, without the need for pre-training. This performance highlights the HRM's unique capabilities in reasoning and problem solving, showcasing its effectiveness in areas where other models falter, much like a skilled player who excels in games that stump others.
So, thank you so much for joining us today. We've had a truly insightful discussion on the fascinating challenges large language models face when it comes to complex reasoning. So, it's clear that while powerful, their current depth and learning methods hit a wall, especially with intricate problems. But as we learned, the hierarchical reasoning model, or HRM, offers a really compelling solution. By intelligently combining its worker module for detailed swift processing and a controller module for abstract, strategic thinking, the HRM tackles these limitations head-on, enhancing problem-solving capabilities in a truly really innovative way. The advancements like one-step gradient approximation and hierarchical convergence are particularly noteworthy, streamlining the training process and boosting performance on even the most demanding tasks. And the results truly speak for themselves, like the HRM's exceptional performance in benchmarks like Sudoku and optimal pathfinding, where even other robust models struggle pretty significantly, truly underscores its potential. It's a significant step forward in developing AI that can really think and reason with greater depth. So thank you again for tuning in, and we look forward to seeing you next time for another deep dive into the world of technology.